isang science. Okay. So, pag define natin yung statistics, it's a science that deals with collecting the data and then preparing the data, analyzing the data, and then interpreting whatever results you have. So, yun yung statistics. Sa atin, sa health sciences, yung term na statistics, medyo pinaganda natin. Ginawa nating biostatistics. So kaya we are looking at statistics and its application on biological sciences. Kaya siya, biostatistics. So statistics in the biological sciences. So yun yung singular meaning of statistic, that the branch of knowledge that deals with collecting the data, analyzing the data, interpreting. Meron din namang plural meaning ng statistic. Yun yung mass of information. Kaya pagka nagba-basketball, ano yung statistics? Ilan na naka-free throw, ilan na yun yung statistics. Similarly, sa nursing, sa hospital statistic, ilan ang namatay? Ilan ang confined? Statistics tinatawag doon. So, yun yung dalawang meaning ng statistics. A singular meaning, the branch of knowledge, at yung plural meaning, yun yung numbers, mass of information, mass of observation.
Okay.
Ngayon, dalawa yung branch ng statistics in general. Statistics. Isang descriptive, tsaka isang inferential statistic. Yan. Kaya pa yan. Descriptive statistic, from the word itself, you are just describing. Okay? So sa under descriptive statistics, there are just two main activities. One is data presentation. So in presenting the data, paano ba natin pina-present yung data? Either textual, such number of such number were admitted in such number from blah 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 blah, parang paragraph. Another way is presenting through the use of table, statistical table. So nandyan yung one-way table, yan yung two-way table or cross-tabulation, and so on and so forth. So tabular presentation. Another way is by using graphs. So pwede kang may pie chart, may bar graph, may histogram, may scatter plot. So yun yung data presentation. So for example, you are being commissioned to run a research that involves the whole population of Saudi. Pagkatapos ka ng mag-research, after doing the research for 5 years, you are given a chance to meet the king. At tinanong ka, pakitaan mo nga ako ano ang data mo. Give me the results of your data. 5 minutes lang. So how will you present your data to the king? Alangan naman basahan mo siya ng napakahaba. So you can use the graphs. You can use the graphs. However, pag gumamit tayo ng graphs, kailangan ng knowledge na ano ba itong x-axis na to, ano ba itong y-axis. Medyo mahirap intindihin. Kaya ang sabi nung secretary ng king, he only has 1 minute to present. Ano mo ngayong gagawin? Dito ngayon yung papasok yung tinatawag nating summary statistics or the summary measures. Ito na yung measures of central tendency, measures of variation, measures of location, etc. So under measures of central tendency, from the word itself, central tendency, the tendency to be at the middle, central. Meron tayong tatlo, at least we have 3. We have the mean, the median, and the mode. Basic understanding ng mean, this is the average value. So in other words, you will take all the values.
Mag-take note.
Gusto niyo, ma'am?
Ayaw mo yan? Meron yan?
Naka-share.
Nakalive.
Okay, good.
You will take all the values, get the sum of all the values from the lowest to the highest, and you just divide the sum by the number of observation. That's the mean. So ang makikita ninyo sa mean, yung pinakamaliit tsaka yung pinakamalaki pumapasok dun sa formula sa pagko-compute. So that the mean is affected by extreme values. Kung meron kang pinakamaliit, meron siyang part dun sa formula. Kung meron kang pinakamalaki, meron kang part dun sa formula. For example, let's say you have a class. More or less, the age of the students are from 20 to 22, something like that. if you will be getting the mean probably is something like 21. Pero let's say for example, biglang may nadagdag na estudyante, accelerated. 10 years old lang siya. What will happen to the mean? What do you expect to happen? The mean will be pulled down. It is being affected by the low observation because that is included in the formula. Similarly, merong isang matanda na nag-decide na mag-second degree ako. 50 years old. Inad mo dun sa 20 to 22 years old. What will happen to the mean? You expect that the mean will go up kasi napupull up nung extremely large value of your observation. There is only one mean in your given data so that the mean is unique. However, mean is not, it is weak in terms of being affected by extreme values. Masyado siyang prone to be affected by extreme values, extreme observation, either be small or be big. That's the mean. Ang layman's term natin sa mean ay average. Yung second example, yung second part naman ng measure of central tendency ay median. From the word itself, it's the middlemost, yung pinakagitna. That's why the median cuts the distribution into half kasi siya yung nasa gitna eh. So, those values equal to the median and below will be the first half, and those values on top of the median will be your second half. So that the median is also equal to what we call P50. Percentile 50. Hindi ba sa NMAT or sa mga exam, anong percentile ranking mo? You belong to the 50 percentile.
50%.
That's the median. Kalahati nung iyong buong distribution. This is also the same as with our decile number 5. Kasi yung decile, hinati mo yung distribution sa 10 maliliit na parte. Yung 5th decile is the middlemost. That is also equivalent to the median. Similarly, yung quartile, you divide the distribution into 4 equal parts. And so, quartile number 2, Q2, is equal to the median. Yung diniscuss kong quartile, percentile, decile, collectively we call them the quantile. And that is another measure of, another summary measure, we call them the measures of location.
Location.
Ito kung assignment na
Nasa drill 3.
Drill 3.
Yun, assignment yun.
So that, sige, mamaya na. So, tandaan lang po natin, nandun tayo sa measure of location. Going back to measure of central tendency, to complete it, the last one is the mode.
Yeah.
The mode is the frequently occurring distribution. So, siya yung pinakamaraming beses mo na-observe. Sometimes, there is no mode. Kasi maaring 10 yung observation mo, iba-iba lahat ng values nila. Pwede rin namang isa lang yung mode. We call that a unimodal distribution. Pwedeng dalawa yung mode.
Try, no?
Bimodal, and so on, multimodal. Meron ba tayong formula sa mode? Wala. Ina-eyeball mo lang, ilan yung pinakamadami. Ilan. Sa median ba may formula tayo? Wala. Yung middlemost. Pagka ang quantity, ang dami ng observation mo is an odd number, syempre meron kang middle. Kunyari 11 yung observation mo, observation number 6 is the middlemost. Paano kung 10? Even. 10 lang yung observation mo. What you do, you get the 2 middlemost, 5 and 6. You get the 2 middlemost, you get the mean of the 2 middlemost. The mean of the 2 middlemost will now be your median. Clear? Klaro po?
Yes.
Question?
Galing mo, bro.
Malinaw?
Malinaw na.
Okay.
Tapos na kami dyan eh.
Hindi, ang importante kasi nito,
Maintindihan
mo,
Ah.
kahit na hindi mo
Basic.
kabisado yung
Yes.
yung definition, you can explain it by heart.
Yes.
Kaya nga eh.
Correct.
Tapos,
Iba
yung
talaga
ba sa
yung binabasa
median may
tsaka may
pinapasok tayo na
nag-explain.
formula? Sa median ba may pinapasok tayo na formula? Wala. So that extreme values will not affect the median. There is only one median, but extreme values do not affect the median. Hindi katulad ng mean, na-apektuhan
Meron,
siya ng
kasi
extreme values.
may
Ang importante sa
formula.
median, sino yung nasa gitna.
Okay.
Okay. So we have measures of central tendency na discuss na natin and measures of location,
Location.
yung quantiles. The third one is the measure of variation or dispersion.
Yeah.
Other term that you will encounter, variation, variability, dispersion, or spread. Measure of spread. Pare-pareho lang po yun. Or measures of homogeneity. Pare-pareho lang siya. Ang ibig sabihin lang nun, gaano ka-spread, gaano ka iba-iba ang mga observation mo from the mean. Remember, kumbaga, ang ating monumento, ang ating starting point will always be the mean. Kasi siya yung nasa gitna. Siya yung average value. So, gaano kalayo-layo? May mga observation na mababa yung value sa mean. May mga observation na malayo yung value sa mean. So that you may have observations like this. If this is the mean, may mga observation dito. May mga observation din naman na dito. So that the spread of the value is telling us gaano sila kalayo from the mean. Meron bang nandito? Meron bang nandito? Ngayon, madaming measures ang measures of variation or spread. A very important one is the range. Basically, ang range is just getting the highest minus the lowest. So that highest minus the lowest is the range. Kaya lang, ang tanong, sinabi ba ng range kung ano yung mga nasa gitna?
Hindi.
Wala. Ang sinabi lang niya, ano yung pinakamaliit, ano yung pinakamalaki.
Okay.
So the utility of the range is not that. So it's not, you cannot use it for many things. It's not giving you enough information. The second important one is the variance. Okay. Variance is just basically the summation of the deviation of the observation from the mean.
Okay, yan pala.
Yan yung formula.
Hindi
Bro,
ko na
formula.
Nag-focus natin na.
Ang E is
Yan
the...
yung formula.
Ito po muna.
Oh.
Kunyari, ito yung mean.
Eh.
May mga observation dito, may observation dito, may observation
pala
dito,
yun.
Yan.
may observation
Yan ako
dito.
ma'am.
Ito yung mean po, ha?
Oh.
Gaano kalayo itong observation? Let's say this is observation number 1. Gaano kalayo? You get that the value, yung layo. Gaano kalayo yung observation number 2 mula dito? You get the value. Gaano kalayo yung observation mula dito? Ito, let's say this is number 3. Gaano kalayo? And this is number 4. You get the value. In other words, you are getting the distance of the observation, individual observation, away from the mean.
Okay,
Some
so-
observation are more, some observation are
Yes,
greater than the
yes.
mean, some observation
Yes.
are
Siya.
lower than the mean.
Okay.
However, pag ginuha natin yung ganyan lang na formula, pag ginet natin yung sum, it will equal to 0. Kasi may mga negative, may
tama,
mga
mga
positive.
malaki,
So, what they do is they get the square.
Yan
Kaya
ang
nilagyan
formula.
ng square.
And then, you divide it by
Yes.
n.
And then yung and may value
minus
siya.
1. Yan, ganyan yung formula.
Yes.
Hindi ko naman kinabisado pero naintindihan ko from the definition.
Kaya nga eh.
Nasulat ko yung formula. Ngayon, kung square ito, let's say this is height in terms of centimeter. In-square mo siya. So dapat ang unit nito, some value with the unit of
CM
square.
squared.
Yes, square centimeters. Paano natin yung interpret? Square centimeter. Hindi bang square centimeter ay area? Height ang pinag-uusapan natin, pero area yun. Let's say, for instance, this is age, years.
No, kaya,
Years,
paano
age.
siya?
Anong ibig sabihin
CM?
ng years, age? Napaka-abstract. Kaya itong mga crazy statistician, they devise another measure of dispersion, which we call the standard deviation. The standard deviation is simply the square root of the variance. This is just the square root of the variance. Ano ngayon ang mangyayari dun? Mag-get mo rin yung square root so that the centimeter will become cm. The year squared will become years. Kasi kinuha mo yung square root. Yun yung relationship ng variance at standard deviation. The standard deviation is just the square root
of the variance.
Malinaw po.
Klaro yun, bro.
Diba?
Klaro yun.
without memorizing the formula, naiintindihan mo lang yung definition. Ngayon, ang sabi, pag daw mababa yung value ng standard deviation or variance, the more homogeneous. Ibig sabihin, mas malalapit sila sa mean. So kung tayo ay gagawa ng tinatawag nating histogram distribution of our quantitative variable, what do we expect the shape of our
Skewed or
distribution?
what? Yun na yun, no?
More or less, matangkad siya na payat. Matangkad siya na payat. Kasi ito yung mean, malalapit
siya.
yung mga observations sa mean. Therefore, we may say that more homogeneous, less spread or less variable. The lower the value of the standard deviation, the less spread are your observation, less variable, more homogeneous. Nagigets mo?
Yan palang meaning. Yan ang hindi ko na-get
May
eh.
hetero ba? Hetero? Yun na yung
Yes.
spread
Kung
niya.
Madami.
napakadami, layo-layo,
Madami.
what do we expect of the distribution?
Okay.
It will become short, but
Mas spreadable.
Wide.
Mas
this is
wide.
narrow and tall.
Wide.
This is short, but wide. Paano natin maiintindihan yan? Gawa ka ng rubber band.
Yeah.
Pagka konti lang yung pull sa rubber band, mas matangkad. Pero i-pull mo yung rubber band on the sides, what will happen to the rubber band? Magiging flat siya, and at the same time, wider.
Yes.
More heterogeneous, more variable, more spread yung iyong distribution. Gets po?
Yes, yes.
Papaano naman, pero wala siguro to dun sa tinignan ko lecture nyo, wala. Papaano naman kung magko-compare tayo? Sabi natin, pagka standard deviation, just look kung sino yung pinakamababa, yun yung pinaka less
Mas
spread na
less spread.
distribution. Paano if you are comparing weight in kilograms and height in centimeters? Pwede ba nating sabihing standard deviation? Kung sino yung pinakamababa sa standard deviation? That is the more homogeneous observation. More homogeneous distribution.
Hindi. Sa dalawang
Iba yung unit.
Iba eh. Yung unit.
So pag iba yung unit,
Dalawa.
hindi natin pwedeng gamitin si standard deviation. What we use is the thing called coefficient
Okay.
of variation. This is the CV. The CV simply our standard deviation divided by the mean. Multiply by percent.
100.
Magiging 100 siya. Percent. So that the CV is in terms of percentage. Coefficient of variation, it's a function of the standard deviation divided by the mean. Times 100 to make it a percent.
So, coefficient of variation is always a percent.
A percent.
Okay.
Yeah.
And so, the lower the coefficient of variation, the more homogeneous is
ito
our
naman is-
observation. Ganun din naman, parang din dito. The
Percent,
lower the
less.
standard deviation, the lower the coefficient of variation, the more homogeneous our observation, our distribution. Clear po?
Yes, the lower, the more homo.
Yes.
The lesser also standard deviation.
Yes.
More homo.
Okay, maliwanag po. Ngayon, sabi nila, paano naman kung ini-standardize natin? In other words, pinokus natin yung ating vista sa gitna. In other words, in statistics, we call that standardized, our values. Pinokus natin yung vista natin sa gitna lang. Tinanggal natin yung mga nasa gilid, yung mga hindi naman masyadong importante kasi they are either too small or too high. Ang tawag doon ay interquartile, IQR, interquartile range. Alam ko na encounter niyo ito, interquartile range.
Drill.
Basically, the interquartile range is a range. And this is just
Arranging.
Q3 minus Q1. Remember,
Yeah.
remember,
Diba
when
Q1,
we have
Q2,
quartiles,
Q1 tsaka 3 lang kaya.
we divide our distribution into 4 equal parts. Q1, Q2, Q3, Q4.
Tapos
Right?
yung dalawa lang pala.
So, ano na natin daw? binista natin sa gitna, finokus natin, tinanggal natin itong part na to, tinanggal natin itong part na to. Because they are not so informative, usually they are extreme values. So what is left?
Q2.
This is 25%, this is 50%. Tama po kasi median, 50%, this is 75%, and this is 100%. In other words, this is 25%, this is another 25%. What is left in the middle? The middle 50%. The middle 50%. So, yung vista natin ay sinentro lang natin sa gitna, which is the middle 50%. And so, to get the range, you get the value of Q3, subtract it from Q1, and so you have the interquartile range.
Yan na yung...
At ginagamit ito sa isang graph na hindi ko alam kung dinis ka sa inyo na tinatawag nating box plot.
Wala.
Wala.
Wala
Never
kami
mind
graph
about
na
that. Pero just so that you know, there is such a thing called box plot. Kasi ito tinawag na box kasi may box siya sa gitna. Tapos meron siyang parang hinihita. Another term kasi dito is the box and whiskers. Kasi may whiskers siya, yung parang ginaganon. So these are the fence of your whiskers. These are your any values outside that will be your outliers. But never mind about this. This is not important at this level. What is important is you know what is IQR, what is coefficient of variation, standard deviation, and variance. Klaro po?
Yes.
Yun po ang katapusan ng descriptive stat.
Mas simpler siya, no? Compared sa inferential.
Yes. Simple siya. Yun lang ang differential
Kaya nga
stat.
gusto nila
Data
descriptive
presentation
study.
and summary
Kesa
measures.
sa ano.
Data presentation, graphing, tabulation, and summary measures, mean, median, mode, standard deviation, etc. Yun po ang
Undergrad,
katapusan.
yan ang ginagamit.
Undergrad.
Yan.
Kasi nga, mas
Apo.
madaling trabahuin.
Yes. Ngayon po,
Galing ni bro.
bago tayo pumunta sa inferential statistics, kailangan munang dumaan muna tayo sa isang importanteng topic, which is what we call the normal distribution. Ang normal distribution, importanteng maintindihan kasi most of your statistical tests will be based on the properties of the normal distribution. Lahat ng mga gagawin yung statistical
For
tests
PhD sa...
ay parametric at pina-follow niya dapat yung normal distribution. Yung normal distribution is basically like this. Alam natin, familiar tayo sa bell-shaped curve, right?
Yes.
Tama po. Sabi natin, sa bell-shaped curve, symmetric. Pagka ikaw ay nag-drawing ng isang linya sa gitna, kung ano yung nasa kaliwa, yun din yung itsura nung nasa kanan. Okay? So, equal sila. And so, from that understanding, we can give the characteristic of the normal distribution. First characteristic of the normal distribution, it's symmetrical. Ibig sabihin, bell shape, left side is similar to the right side. The second important characteristic of the normal distribution is that the mean is equal to the median is equal to the mode.
Okay.
At lahat sila
Kasi
ay nandito
normal
sa gitna. Which is the mean is equal to the median. Ang basa po dyan ay x tilde. X tilde.
Still din.
Yung ano.
Ganyan.
At sa mode.
Mode.
Ayan pa lang mga niya. Symbol.
Mamaya didiscuss ko pa ibang symbol para hindi kayo ma-confuse. Pero for now, ang gagamitin ko lang muna ay x bars. So this is the mean, the median, and the mode. Okay. Now, so sabi natin, pare-pareho sila, nandoon sila sa gitna. Okay. The third property is, kita nyo po, hindi ko siya sinagad. Hindi siya nag-touch sa x-axis. It extends on both direction without touching the x-axis. It will come so close but never touches the x. Ang tawag po dun ay asymptotic property of the normal
Distribution.
distribution. Asymptotic property.
Not touching the axis.
Yes.
Ah.
Okay. Now, babalik muna ako dito sa number 2. Papaano kung yung mean is not equal to the median, is not equal to the mode? Kanina sinasabi ni ma'am yung tailing. Meron distribution na, may ganyan, di ba? Meron naman distribution na ganito. Right? This is, ang tailing nito ay nasa left
To
side.
left. Oh.
So this is a
To the
negatively skewed distribution. Negatively skewed
To the left.
distribution. On the other hand, ang tailing nito ay nasa right side. This is a positively skewed distribution. Now, paano natin malalaman kung ano yung skewness niya? If the mean is less than the median, that is a negatively skewed distribution. Less than the mode. Because yung pinaka-apex, yung pinaka-matangkad will always be the mode. Kasi nga siya yung frequently occurring. Siya yung pinaka-madami. Siya yung pinaka-tuktok. Siya yung pinaka-matangkad. And here naman, nauna yung matangkad. So the mode is less than
Less than
the median, less than the mode. Sorry, mean.
Kasi pabalik.
Yes, pabaliktad. So nakikita niyo po yung hierarchy. In here, pinakamababa yung value ng mean. In here naman, pinakamalaki yung value ng mean. Yung mode, madaling tandaan kasi siya yung pinakamatangkad. Yung median, pinakamadaling matandaan kasi siya yung nasa gitna ng median at mode kasi nga siya yung middlemost value. Nag-gets niyo po? Negatively skewed, positively skewed. Pero pag sila ay pantay-pantay, this is a normal distribution. Klaro po? Okay. Symmetric, mean, median, mode are all equal. Asymptotic. Okay. Number 4. The total area under the curve is equal to 1 square unit or 100%. The area under the curve, di ba natatandaan na naririnig lagi na AUC, area under the curve. Sa pagbibigay ng GAM, di ba sa pharmacology naririnig niyo yung the area under the curve. Yan. The area under the normal curve, itong area na ito, is equal to 100% or equal to 1 square unit. Klaro po? Okay. So, 100% yung area under the curve. Number 5. The normal distribution is being described by 2 parameters. One tells us the location. Location. In the x-axis. Saan siya? Nandoon. Nandito ba siya? Nandito ba siya? Nandito ba siya? So, if I have 3 distribution, at meron akong 3 distribution, meron din akong 3 mean, right? So, have x bar 1, x bar 2, x bar 3. This is the x-axis, ha? The x-axis. So, mapapansin ninyo, mean 1 is less than mean 2, is less than mean 3. Therefore, the mean is telling us the location of the distribution. It tells us in the x-axis, saan mo matatagpuan itong distribution na ito? Dito. Itong distribution na to, nasa gitna. Itong distribution na to, nandito to. Therefore, the mean of the distribution tells us the location of the distribution in the x-axis. Nagigets po ba? Because the mean is the middle of the distribution. Kung saan nakasituate yung mean, I have here, in this case, I have 3 distribution. It tells me, sino yung mas unang lumalabas sa x-axis? Yung nandito, yung nandito, o yung nandoon. So, the mean tells us the location. Ang tawag sa kanya, location parameter. The other one tells us the shape. Let's say, for example, meron akong 3 distribution. Oops. Tapos, oops. More or less, ang mean niya ay pare-pareho. Right? Kasi, pare-pareho silang situation, right? Pare-pareho yung location nila. Pero look at the shape. May matangkad, napayat, merong mababa ng konti, at merong flat na. Therefore, if this is A, this is B, and this is C, our standard deviation, sigma, in this case, ano yung pinakamababang sigma? Diba sabi natin, the smaller the standard deviation, the taller it is. So, sigma A is less than, sigma B is less than, sigma C. The standard deviation of the A is smaller than the standard deviation of B, and which is smaller than C. Kasi the smaller the standard deviation, the more
homogeneous.
narrow, the taller.
Taller.
The bigger the standard deviation, the shorter, the wider. Di po pa? The more heterogeneous. Homogeneous, heterogeneous. Klaro po?
Yes.
So that is the shape parameter, our sigma, our standard deviation. Shape parameter. Okay
Pang
po.
number 6 na yun.
Number 5 lang po yun.
Under
Number
pa rin
5.
siya sa 5.
And lastly, number 6. The total area under the curve is equal to 100%, right?
Yes.
So that if this is the mean and you are one standard deviation, positive 1, negative 1 standard deviation away from the mean, this area here is already covering 68 and 1/4 of a percent of the total area under the curve. Meaning to say that if the total area is equal to 100%, mula sa gitna, mula sa mean, hinanap mo yung one standard deviation below the mean and one standard deviation above the mean. Kumuha ka ng cutter, hiniwa mo, yung natirang area ay already 68 and 1/4, 68 and 25%
Constant.
of the area. That's a constant. Okay. Klaro po yun.
Hindi pala 50% yan.
Hindi po 50%. It's 68.14. Kinuha nila yan sa pamamagitan ng calculus. Medyo mahirap yung derivation. Pero wag na natin pakialaman yun.
Basta yan constant.
Komplikadong
Oh,
buhay. Wag na
constant.
natin pahirapan ang sarili natin. Okay, constant po siya. Ngayon naman, kung ito yung mean, 1, negative 1, standard SD, negative 2, standard SD, positive 1, standard SD, positive 2, standard deviation. Kumuha ka ng kutsilyo, hiniwa mo to. In other words, 2 standard deviation on both sides, negative and positive. This area here is already covering 95 and 1/2%.
Okay.
95 and 1/2%, or
Yung dalawa na,
95.5.
tatlo. Yan, 1, 2, 3, 4, 5.
Yes, kasi po 2 below, 2 above.
Above.
Eh ngayon, kung 3 standard deviation na, negative 1, negative 2, negative 3, positive 1, positive 2, positive 3. Hiniwa mo na naman siya. The area under the curve now is already 99 and 3/4 of
Hindi
a
pa
percent.
Oo.
Hindi, why is it not
Kasi-
100%?
Oo.
Sabi natin sa number 3, it
hindi,
extends
kasi-
infinitely.
Kasi wala siya nag-touch. So, hindi siya
It
mag-stop.
extends infinitely,
Kasi-
hindi siya nag-stop.
Kaya nga,
It will approach but never touches.
touches the axis.
Kaya
Okay.
hanggang 99 to 0.75 and so,
wala
on and
pala
so on
talaga
and so on and
perfect
so
na.
on.
Di ba? Bawa, sa study ba? I mean, sa research.
We are only
Diba?
estimating.
Yeah.
Kasi only God knows the
yeah, the
true
perfect
value.
one.
Okay. Maliwanag.
Kaya, ganyan pa.
Yan, pag titignan ko,
Galing mo
naalala ko siya.
Kaya nga, yan na lang.
Kaya, photocopy ko yan, ha? Kasi just by looking at it, I will remember the way you're explaining it. So,
video, ma'am.
kaya nga. Pero kahit pag
Photocopy,
titignan ko
tsaka
siya,
video. Siyempre.
Okay, so napagdaanan natin ang
Normal.
normal distribution. Bakit importante si normal distribution? Kasi po, yung normal distribution, yun yung number one assumption sa parametric test, that they are supposed to be normally distributed. Ang assumption is that they are normally distributed.
Yeah.
But I will go to that later. But for now, maraming normal distribution, basta bell-shaped curve, normal distribution. This is a normal distribution. This can be another normal distribution. Basta bell-shaped curve, normal distribution, right? Kaya lang, yung normal sa'yo, pwedeng hindi normal sa'yo, hindi normal sa'yo. Normal din yan sa akin. Itong mga crazy statistician, they decided to standardize it. That's why we have the thing called standard normal distribution. So we have the thing now called standard normal distribution. Standard normal. Kumbaga, in-standardize natin. Kumbaga, kung ito ay peso, ito ay real, ito ay dollars, let's have a common currency. And that is the standard normal distribution. What makes the standard normal standard is that the mean is equal to 0. And its standard deviation is equal to 1. In other words, if this is our distribution, its mean is equal to 0, and the standard deviation is equal to 1. That makes the standard normal the standard normal.
Kasi iba
All
yung
the
sa
other
normal.
all the other characteristics are true, plus the mean is 0 and its standard deviation is equal to 1. That's the standard normal. Eh, paano ba kinukuha yung standard normal values?
Yeah.
Naririnig nyo na yung Z deviates, the Z value, which is simply our observation minus the mean divided by the standard deviation. In other words, gaano nag-a-agree yung obserbasyon mo sa kanyang mean. You are getting the concordance, the agreement between the observation and the mean. And then you are dividing it by the standard deviation. That's the Z value. And this is a generic formula for all statistical tests that you will encounter. Either it be the C test, the T test, the F test, everything will be based on this generic formula. Ganun ka-importante si normal distribution sa statistical inference kasi yung mismong formula niya ang pinaka-baseline formula. Ito yung pinaka-model formula for all the different kinds of statistical tests. Maliwanag po.
So, isa lang. Yan lang.
Yeah. Pag alam mo to, magagawa mo yung ibang formula. In
Ito
other
yung
words,
symbol
pero
ng
marami
standard
pa yan.
deviation.
Marami pa yan, di ba?
marami pa.
Marami yan. Mamaya yun i-discussin mo.
Maliwanag po. Okay.
Mamingi lang po ako ng tubig
Oh.
pala.
Ako din.
Break mo na.
Break muna.
Break.
2 minutes.
Tubig muna, tubig.
Pero pakikinig po muna ako.
Hingi na tubig dyan.
Ako okay lang, may ice ako.
Galing mo, Sir Edric. Grabe. Ako talaga, nung sa master hall ko, pasangawa lang din ako. Yung para lang makatawid talaga, makapasa.
Actually, yung, kahit naman yung mga estudyante ko sa master tsaka estudyante ko sa PhD, usually ayaw nila ng stat kasi number. Kaya lang ang ano namin, ang sabi namin sa kanila, our mission for you is to love statistics. Na hindi kayo na-intimidate.
Yeah, really.
Oh, kasi makita lang yung mga Greek letters intimidating na kagad.
Kaya mo.
Yun palang makita, wala na. Back out na.
Yung mga estudyante naming madres, paano yung gagawin
Back out na.
namin? Sister, aral po, sister. Sabi niya, sir.
Akin
Ay,
yan.
sorry po.
Hindi, nagamit ko na eh.
Ano talaga pagka yan?
Mga
Sa
ma-
word pa lang ba, mga terms? Ala, saan ba yung kinuha?
Yung
Ah, mas
mga-
pag nakita
yung
mo na yung mga symbols, mga formula.
Oh,
Wala na.
kasi dyan wala kasi ditong ano, di ba? Walang formula binigay, di
Yung
ba?
mga madre, sister, sir, di ko na nga nahawakan yung rosaryo. Scientific calculator na nga yung hawak ko.
Kaya nga, kasi nga mahirap intindihin.
Okay. So, alam na natin yung descriptive, yung isang branch. Tatawid na tayo dun sa pangalawang branch, which is statistical inference.
Okay.
So, sa statistical inference or inferential statistics, meron tayong population. Let's say, population ng Saudi, around 35 million. Napakalaki. Eh, kung ikaw lang yung researcher, alam nga naman, paano mo gagawin yun? Baka naman nagsimula ka na, single ka, hindi ka pa nangangalahating mag-data collect, aba, meron ka ng lung cancer at malapit ka na matigok. Nagsimula ka na, single ka, aba, meron ka ng 3 apo, hindi ka pa rin tapos. Okay? So, what we do is, we get a sample. And then, we observe the sample. We observe the sample. Yun yung mineasure natin. Doon tayo kumuha ng data sa sample. whatever conclusions we generate out of observing the sample will then be generalized to our
So
population.
general population.
That is the idea. That's the fundamental idea behind statistical inference. You have a big population, you get a representative sample which we call the sample,
Example.
and we observe the sample, we do the measurements in the sample, and then we gather information, and then we generalize the information to our population, to our target population. Such that
Something.
in the population, we have the values called parameters. Diba? Meron tayong mga parameters. This is from the population. So that the mean is represented by mu. The standard deviation is represented by sigma. The proportion is represented by capital letter P. Right? Yeah. And so on
Sigma.
and P.
Dami.
Ngayon, kung sa sample naman siya nagmula, we call that statistic. Statistic. And so the mean is represented by X bar. The sigma is represented by S, or yung iba ginagamit SD. And the proportion is represented by small letter P. Madami pa yan. Let's say, for example, darating kayo sa tinatawag na coefficient of correlation or the Pearson product moment correlation coefficient. We are computing for the R based on the statistics. Pero ang parameter niya ay ang Greek letter rho.
Iba pala ang sa parameter tsaka ang stat.
Ang
ang
statistic,
symbols, ano.
kung regression analysis, this is just the beta coefficient, the B. But for the parameter, this is represented by the Greek letter beta.
Yeah.
Okay po. Yan. So, yan yung parameter statistic. Parameter are constant. Isa lang naman yung value ng parameter sa population. Yung mean ng 35 million Saudi, mean age ay constant. Kasi everybody's included. However, sa statistic, kasi nga nag-sample ka, yung sample na nakuha mo ay iba sa sample na makukuha ko, iba yun ang sample na makukuha mo. Pag kinompute mo yung mean, iba yung value ng mean mo, iba yung value ng mean ko, iba yung value ng mean mo. Statistics are variable. Hindi siya constant. Parameters are constant values. However, only God knows the value of the parameter. And so, out of doing the sample, we can estimate. We can estimate the value of the parameters using our statistic. Thus, the estimator of mean, mu, is the X bar. The estimator of capital P is the small letter p. The estimator of sigma is the SD. Nagigets po? We are estimating.
Kaya sa stat.
Estimation is one of the important activity under inferential statistics. It's one of the important activity under inferential statistics, which is estimation. Now, sa estimation, let's say for example, Ma'am Jenny, ano sa tingin mo ang aking weight? You can tell me, sir, siguro ang weight mo ay 160 kilos. You are giving me one number. And that one number is what we call a point estimate. Point estimate. One single number. Meron namang klase ng estimate na sabihin mo, Ma'am Jenny, siguro sir, ang weight mo ay nasa between 120 to 170.
So may range.
May range. May lower limit at may upper limit. At sasabihin niyo sa akin, pero sir, mga 95% sure lang ako dun, ha? 95% confident lang ako. That is what we call an interval estimate. So, point estimate is a single number. An interval estimate has a lower and an
higher
upper limit plus a level of confidence. Kaya naririnig nyo yung 95% confidence interval estimate. 90% confidence
Sa
interval.
mga ano, no?
Sa mga
Statistical
journal,
ano
di ba?
nila.
99% confidence interval. Kasi we are just only estimating the value. Only God knows the value. We are just trying to
Correct.
approximate.
Yeah.
Okay. Gets po. Ngayon, bakit ba nilalagyan natin ng 95% level of confidence or 99% or 80%, 95%? A very practical way of interpreting that. This is a practical way of interpretation. If you say that my weight is somewhere between 120 to 160 and you are 95% confident about it, you're simply saying that I am 95% confident that your weight is anywhere
From 120
within
to-
this range from 120 to 160. That's a practical interpretation of it. Pero in a stricter sense, sa statistics, pag ininterpret natin itong confidence interval estimate using the frequentist technique, if we will be repeating the sampling, I will do the sampling, you do the sampling, you do the sampling, you do the sampling, 100 times, 95% of the samplings that we will be doing will capture the true value of my weight.
So from
Medyo ano daw? Repeat it 100 times. 95% of the samplings will capture the mean. That's the frequentist way of interpreting the confidence interval estimate. Medyo mahirap intindihin. Pero on the long run, basta in the long run, 95% ng mga sampling nyo magko-contain ng mean. Mahirap. So, a way to do it, to better understand it, is using the practical way of interpreting, such that 95% confident that your value, your mean, your weight, or whatever it is somewhere between the lower limit to the upper limit. Although, that interpretation is from the Bayesian statistic. Dalawa kasi ang statistic, isang frequentist, isang Bayesian. Huwag na tayong pumunta doon, medyo komplikado. Basta ang importante, ganun lang pala yung sabihin ng 95% confidence interval estimate na nakikita ko sa mga journal.
Oo.
Yun lang pala yun.
Yun pala.
The point estimate will be in the middle of your confidence interval
Kasi yun yung
estimate.
mean.
Kasi siya yung nasa gitna. Okay? So, one activity under statistical inference is estimation. The other activity, which is of similar importance, is hypothesis testing.
Yan na yung
Yan na yan. Papunta na tayo dyan. Yes, po.
level of significance.
Hypothesis testing.
Kaya nga, ang daming trabaho ng ang tawag nito?
Ano po?
Quanti. Di ba? Ang quantitative.
Pero medyo bias kasi ako. Mas nahihirapan ako sa
Quanti.
qualitative.
Quali?
Mas madali ang quanti.
Quanti. Kasi may talagang figure and all. Ang descript kasi daw, yun yung teaming, madami ka pang, di ba?
Meron kang content
Pero ang
analysis, thematic analysis,
yun.
looking up for the common themes.
Teams.
Mahirap kasi siyang gawin.
Sige.
Okay, anyway. Statistical testing. Ang hypothesis is a statement
Yeah.
which we would like to know. A statement
Yes, yes.
about
Yes.
Yes, a statement about the population. It usually involves the parameter, the value of the parameter mu or capital P. Yan. And we would like to know whether we have sufficient evidence to claim it, whether it is true or not true. Okay. So, statistical hypothesis testing is basically an activity as if you are the judge in a court, whether you will tell that that statement is true based on the evidence or that statement is not true and it's not being supported by the evidence. Saan nakukuha natin yung evidence? Remember, if you have the data, collect the data, and you come up with a distribution, more or less you will be coming up with a histogram, right? And you can come up with a normal distribution. According to the central limit theorem, as you increase the sample size, no matter how skewed the distribution is, more or less it will approximate the normal. It will approach the normal as you increase the sample size. That's the central limit theorem. As you increase the sample size, more or less, the distribution will approximate a normal. Magiging normal din siya, basta tinaasan mo yung number ng samples. Okay. Saan natin nakukuha yung evidence? Tandaan nyo yung 3 standard deviation away from the mean, 2 standard deviation away from the mean. The middle part here is the area of high evidence, high probability of occurrence. And those areas here are the areas of low probability of occurrence. In other words, tinitingnan natin yung high probability of occurrence in order for us to decide whether we are going to reject or not reject the null hypothesis. Okay. It's always about the null hypothesis, HO. Null hypothesis is the hypothesis of equality. For example, you are comparing one's population and another population. You get a sample from those two populations, you observe them, and see whether the mean of this population, of this sample representing the population 1, and the sample representing population 2 are equal. In other words, your null hypothesis is simply mu A is equal to mu B. Kasi hypothesis of equality daw eh.
Ang dalawa.
This is similar to saying mu A minus mu B is equal to 0. Kasi kung
Kasi
0
equal.
siya, 1 minus 1 equals 0. Equal sila kasi 1, pareho silang 1. It's just the same. So, null hypothesis is the hypothesis of equality. It's the hypothesis of no difference. It's the hypothesis of no correlation. It's the hypothesis of no association. Kaya nga siya null.
Ayun, difference.
Kaya nga
nga,
null
oo.
nga. Null. No
Kaya,
difference,
oo.
no association, no correlation, nothing.
Nothing.
The alternative hypothesis, we use HA or H1, yung iba H1, it's the opposite. It's the hypothesis of difference. So MA is not equal to MB. Or it can be written as mu A is greater than mu B,
Yes.
or mu A is less than mu B. Nagigets po?
Kasi hindi sila pareho.
Hindi sila pareho. Kung ito ay association, kung dito sa null ay no association, dito they are associated, or they are related, or they are correlated, something like that. Now, dalawa yung klase ng ng alternative. Isang, they are just not equal. Isa namang, one is greater than, or the other one is less than. Ganon. Pagka ganito lang siya, non-equality, this is called a two-tailed. Two-tailed. Kasi sinabi mo lang na hindi sila equal. Pwedeng mababa yung isa, pwedeng mas mataas yung isa. No direction. That's why this kind of null hypothesis is called a two-tailed null or non-directional. Two-tailed alternative or non-directional alternative hypothesis. On the other hand, ito, meron ng sinasabing direksyon. Isa ay mas mataas, isa ay mas mababa. This is a one-tailed alternative or a directional alternative. Nagigets po?
Not equal to.
Not equal to two-tailed.
Yeah.
Pero pagka
Lesser
greater
and
than less than,
greater.
one-tailed na siya. Klaro po?
Yes.
Okay. Importante yan kasi later on, yun sa ating
Tumiting sa
critical
ano,
region, magagamit natin yan. Okay. Ang hypothesis testing will always lead to a conclusion.
Yes.
Either you will reject or not reject the null hypothesis. Okay. Dun sa mga lumang statistical books, maririnig yung term na accept the null.
Yes.
Pero now, we are changing that. Not reject the null. Bakit kamo? Kasi ganito po. Let's say, ang hypothesis mo, lahat ng baka ay itim. Lahat ng baka daw ay itim. Papaano kung sa buong buhay mo, from, kunyari, ikaw ay 40 anyos na ngayon, mula ikaw ay nagkaisip hanggang ngayon, lahat ng baka nakikita mo ay itim. So, ang statement mo,
Lahat talaga.
sorry, not baka, kalabaw.
Kalabaw.
Lahat ng kalabaw ay
Kasi itim. Baka is
Baka may
itim.
puti. Paano kung 2 days from now ay nag-travel ka at may nakita ka bigla
Brown.
na kalabaw na puti, albino na karabaw.
Oo nga. Meron nga, albino.
So, will
Maiba.
accepting
Oo.
before, kasi inaccept mo na
Oo.
yung fact na yun eh. Will accepting that, ngayon meron ka ng evidence na hindi pala siya tama. Nire-reject mo yung accept mo? Parang sinubo mo na, iluluwa mo
Luwa.
na. That's why, accepting an hypothesis is not equal to not rejecting the hypothesis. Acceptance is not equal to non-rejection. For now, you are not rejecting it because you do not have the sufficient body of evidence. But that doesn't mean that you are accepting.
Accepting.
Yeah.
You are not rejecting yet
Yes.
because the body of evidence is not sufficient.
Oh.
Okay po. So yun yung difference ng not reject sa accept.
Accept.
We do not accept hypothesis. We simply do not reject.
Ah.
Hypothesis testing is always about the null. Null is written such that in the long run, it may be rejected. Kaya siya null, nothing. Okay. So yun po yun. So if we will be rejecting the null, we'll go with alternative.
Yes.
If we will not reject the null, well, we say that we do not have sufficient evidence to conclude the alternative. Ganun lang naman siya. Okay. So, ang tanong, paano namin malalaman kung reject or not reject? Ano yung basis? Ito ngayon yung gagamitan natin ng mga statistical tests. At dyan napapasok yung assignment nyo na t-test. A statistical test is like a diagnostic test. Screening for, let's say, screening for uterine cancer using probably pap smear or acetic acid wash or screening for glucose for diabetes using fasting glucose level. Ganon din yung diagnostic test, ganon din yung mga statistical tests. It will help us make a decision whether we will reject or will not reject the null. It's always about the null. Ngayon ang question, paano pagka nag-reject ako ng null, yung palang null tama. You are rejecting a true null hypothesis. In that case, you are committing an error. And that error is called a type 1 error or an alpha error. An alpha error, para po madali nyo matandaan, is just ART. Alpha is rejecting the null hypothesis when in fact it's true.
Okay.
Art.
Art.
Alpha error is an error that you committed
Rejected.
when you
The
reject
The
the null
When it's true.
when it's true.
Okay.
Ano naman yung, natatakot ako, wag ko na lang i-reject. Kaya lang, mali naman pala. Bakit hindi mo siya na-reject? You're committing a type 2 error or a beta error.
Alpha, beta. Okay.
Pharmacist ako. So, ang ginamit ko dyan is BNF. This is the British National Formulary. Beta error is non-rejection of the null when in fact it's
It is
false.
false.
Beta error is rejecting.
Alam ko nasa assignment nyo yun, yung alpha tsaka beta sa first assignment nyo.
It's false.
First assignment?
Drill 1. Drill
May beta ba doon?
Type 1 error, type 2
Type 1.
error.
Ay,
Type 1,
type
type 2.
one. Oh, yun.
Type 1, type 2.
So type 1 is alpha, type 2 is beta. Clear po?
Naintindihan ko na siya dati. Copy-paste ko lang yun eh. Pero binasa ko naman. Nakita ko lang yung alpha at saka beta. Kaya wala.
Ngayon natindihan, yun lang pala yung beta, yun lang pala yung alpha
Ay.
error, yung RT lang pala, tsaka
Ala,
BNF.
oo.
Alpha pala nag-reject ako pero mali yung ni-reject ko.
Yan
Natama
palang
pala yung
alpha,
ni-reject ko.
Diyos ko. Yan palang yung beta. Ayan na.
Mamaya babalikan
At
uli
least
natin si
simple lang
alpha.
ba?
Mamaya babalikan uli natin si alpha. Question po.
Alpha is rejecting the null
When it is true.
BNF,
Rejecting the null when it is false.
Not
Tama, no?
rejecting.
Not rejecting.
When in
the
fact
null
it's
is
false.
Okay.
Klaro po.
Not rejecting, rejecting when it's true. Not rejecting when it's false.
Yes. Okay. Now,
Art and BNF.
so ngayon, okay. So alam na natin yung mga error, alam na natin yung hypothesis. Ngayon, ang tanong, paano tayo ngayon magde-decide whether we will reject or not reject? There are 3 ways. Number 1, ito yung gusto nyong, alam ko ito yung ayaw nyong mag-compute ng t is equal to x bar minus compute. Kukunin yung likuran ng book, looking at the t table, getting the value, getting the critical region, this one here, region of rejection. In other words, you get the value of your statistic, of your test statistic. In this case, this is a t or it can be a z-test. Get the value and compare the value against your critical region. If our alternative is simply a two-tailed test, let's say this is a two-tailed test. Let's say, for example, we have C-tests and we want a 95% confidence level. Alam ko, natatandaan nyo to, 1.96,
Yung mga ganun.
1.64, 2.58, natatandaan nyo pa ba yun? Sabi ng teacher namin, pag daw in the middle of the night, pag may nagtanong sa'yo, tumawag sa'yo, nalimpungatan ka, alam mo pa rin na 1.96. Ang Z, that is equal to, Z is equal to 1.96. For an alpha, that is equal to 95%. Yung mga ganon. Anyhow, yung ating, sabi natin, ito yung high probability of occurrence, ito yung low probability of occurrence. Let's say, for instance, this is positive 1.96, this is negative 1.96. Any values of your test statistic that will fall somewhere here to even higher values, dito sa area na to, that will lead to the rejection of your null. Similarly, any values which is equal to negative 1.96 or the smaller ones here will also lead to the rejection of the null. In other words, this area here and this area here are the rejection zones. This area here is the non-rejection zone. Nagigets po? That is using the critical region. Kung gusto niyo mag-compute. Nagigets po? That's one way. So pagka ang C-test mo, ang T-test mo, ang value na nakuha mo dito, let's say for example ay 36.5, nasan siya? Nandun siya sa greater than 1.96. So nandun siya sa reject. So reject the null.
Okay.
Reject the null. Let's say for example nakuha mo negative 0.5. Nandito ba siya o nandito siya?
Dito.
Ito po yung 0 Negative
Dito,
0.5.
diba?
Nasaan yung 0.5? Negative 0.5. Di ba
Tama
nandito?
ako?
Nandito
Yeah.
yung negative 0.5. So
Kasi-
nasa non-rejection zone siya. Do not reject the
Rejected.
do not reject the null. Nagigets nyo po? So ganyan po yun.
Galing.
That's one way.
Yan sa, dito, no? T-test.
Yeah. C-test, T-test, chi-square test, kung ano man yung kinumpute nyo. That's one way. Another way is looking for, ito yung gusto ninyo, p-value. P-value. P-value is the probability of observing the test statistic and the more extreme values. Ang hirap naman ano ba yung ibig sabihin ng observing the more extreme values. In other words, ang pinaka-importante dito na kailangan nyo malaman, you set the alpha, right? You're setting the alpha. Gusto mo 0.05, 0.1,
Okay.
0.01. Di ba? Ganyan yung mga usual. Pagka 0.5, this is 95%, this is 90%, this is 99%. Ganyan lang naman yun. Let's say alpha is 0.05. The computed p-value that you obtain is, let's say, for example, 0.0001. Is this less than alpha or greater than alpha?
Ay,
This is less than
0.0.
alpha.
Less.
Less than alpha. Tama po ba? Agree.
Yes.
Agree. This is less than alpha. So, if the p-value is less than alpha or equal to alpha, this leads to rejection of the null. If
Equal
the
or less.
p-value is greater than alpha, we will not reject the null. When we reject the null, we conclude that there is a statistical significant difference. Kaya ito yung statistical significance. Kaya yung ibang tawag sa hypothesis testing, significance testing. Is it significant or not significant?
No.
Di ba? Ganun lang naman. Significant or not significant? Kasi nga, pagka nireject mo yung null, significant yung result mo. Kasi hindi ka nga. Merong value, may silbi. May pagkakaiba siya statistically. Pero pagka hindi mo
No
nireject
rejection.
yung null, non-significant yung result mo. Insignificant, statistically insignificant. Using the p-value approach.
Okay.
Pero as an epidemiologist, we do not recommend the use of p-value. Tawag namin, you should not be too p-driven. Bakit? Kasi ikaw ang nagsiset ng alpha.
Kaya,
Paano?
Paano
Hindi daw significant. Taas natin, gawin natin 0.01.
Pwede.
Pwede mo siya i-manipulate.
Pwede mo siyang i-manipulate.
Yan.
Kaya do not be too p-driven. So a way to provide more information is using the confidence interval. Di ba kanina diniscuss ko 95% confidence interval estimate. Sa confidence interval estimate approach, ganito naman yan. Let's say for example, the null is stated such that mu A is equal to mu B. Anong way of writing this? Mu A minus mu B is equal to 0. That's why the null value here is equal to 0. Let's say for example, the 95% confidence interval is from negative 0.98 up to 10.30. Yun po bang null value ay nasa loob ng estimate natin?
No.
No.
Negative.
Ay, negative kasi 0 yan.
Yes,
Oo.
yes.
To 10.30. Nasa loob ba siya? In other words, yung Pokemon ay natagpuan mo sa loob ng confidence interval. Pag nakita mo yung Pokemon sa loob, yung null value, hindi mo siya pwedeng i-discount because there is certain probability na ma-encounter mo yung null. Hindi mo pwedeng
Walang bahala.
Walang bahala. Kasi yung zero,
Meron
yung null
pala.
value ay
Oo,
nasa loob.
Nasa loob siya.
And this provides us more information than the p-value.
Yes.
Kasi,
Let's say for example, ang nakuha mong 95% confidence interval ay 0.20 up to 5.4. Yung ano po yung null value natin? In our case, 0.
0.
Nandito po ba sa loob yung 0? Yung Pokemon ba ay nasa loob? Wala. Therefore, we will reject the null. Kasi yung Pokemon wala naman sa loob. Wala tayong pagkakataon na makita yung Pokemon sa confidence interval.
Wala negative.
In other words, significant yung ating result. Gets po?
Bakit lang ginagamit ang p-wave? Ang p-wave? Ang
P-value.
Usually, sa mga journal, makikita mo p-value ginagamit nila.
Oh,
Ano kasi
nakita ko
kami,
yan.
ng
Undergrad thesis.
coefficient kami before sa yung article namin.
Coefficient of
Yung
correlation coefficient.
correlation.
With the correlation coefficient, na kinumpute mo ay small letter r. Small letter r.
Ganyan. Meron.
Ito is based from the
ano.
sample. Now, to test whether yung na-observe mo sa sample is also true to the bigger population, we will test for the significance of the hypothesis that rho is equal to 0. Yung if rho is equal to 0, na-observe mo nga sa sample mo, pero sa totoong buhay naman pala, sa bigger population, kaya si Hodang, ano yung relationship nila? 0 lang pala yung rho. So ngayon, anong gusto natin? We want to reject this hypothesis, right? That's why we are aiming for the significance of R. So we are looking at a p-value that is less than our alpha. So yun ang gusto natin yun sa rho. So, chine-check ngayon natin yung p-value ng R, kung yung p-value mo ba ay less than alpha. Kasi kung less than alpha, significant siya. Okay po. Ma'am Jenny,
Ito.
anto ka na.
Pero ito talaga, ikaw ang magagawa.
Ito yung
Magsiset
ginagamit.
ka. Di ba? Magsiset ka talaga. Ano,
Ito yung
kape-kape?
ginagamit.
Oh, natay kape dia.
Okay. Pero bago tayo pumalaot, ang statistical significance, ang niro-rule out ay ang epekto ng chance. Dahil lang ba yan sa chance? Kaya na-observe mo yan? Dahil it's just ruling out the role of chance. Sa konteksto ng epidemiology, this is what we call random error. We are removing the role of random error. Baka yun na-observe natin na values ay dahil lang sa chance. Kasi naman, yung mga nakuha mong sample ay ganun. Sila pala yung nasampulan mo. It's just removing the role of chance. Pero sa epidemiology po kasi, more than chance, there are other possible explanations such as systematic error, which we call bias, and the role of a third variable, which we call confounding, or the confounder, kung narinig nyo na siya previously. Pero sa statistics kasi, chance lang. Significance testing is just looking at the role of chance, the role of random error. Pero, pag tinaasan mo yung sample size, you will be able to bring down the random error. Okay? Ganito lang yan. Balik tayo dun sa estimation. May nag-exam yung mga estudyante ng provider 4. Hirap daw ng nursing provider 4. Babagsak yata sila. Yan nakayanan. Pumunta siya dun sa admin building. Ano yun? Apat na palapag, di ba? Pumunta siya sa tuktok. Gusto na daw niyang tumalon. So ngayon, ang tanong, may darating na rescuer. Unang dumating yung taga-KFU. Nilabas nila yung pangsalo nila. Tinanong sila, anong confidence nyo na masasalon nyo siya? We are 90% confident. Nilabas nila 10 by 10 meters yung pangsalo. Maya-maya, dumating yung rescuer galing sa Caldia. Nilabas nila yung pansalo nila. 20 by 20. Medyo malaki. How confident are you?
99.
90, yung isa 90, di ba? Ito 95%. Dumating yung taga-Mubaras. Medyo high-tech daw sila eh. Nilabas 50 by 50 meters. We are 99% confident. In other words, as you increase the level of confidence, what happened to the interval estimate? It becomes wider. Lumalapad. Less precise, but wide. In other words, Ma'am Jenny, anong weight ko? Sir, siguro ang weight mo nasa 50 to 60. Pero 90% lang ako. Bro, anong weight ko? Bro, siguro ang weight mo nasa 130 to 180. Medyo wider. Pero 95% lang ako. Ma'am Jenny, anong weight ko? Ay, sir, ang weight mo siguro from 100 to 500. Pero 99% sure ako na nando doon. The higher the confidence, the wider the interval estimate. Okay po tayo doon. Pero
The higher the estimate, the
Yes.
wider.
yes, the higher the confidence level, the wider will be our confidence interval estimate.
Confidence level. Okay.
Question po. Ano ma'am?
Kape-kape, nantok na oh.
Ayos lang.
Hindi na maintindihan.
Kape.
Init tayo.
Painit na din!
Break.
Break muna.
Break.